Assalamualaikum and salam sejahtera. So my name is Muhammad Amin bin Samsudin. So I would like to thank for giving me the opportunity to present my dissertation one about a case study on rolling stock refurbishment maintenance strategy to sustain the reliability and performance of the passenger urban rail transit system in Malaysia. Okay, so this is the chapter one for introduction. Okay, for the research background, so rail transportation service has become the first choice mode of public transportation in the city centre. Providing reliable rolling stock is essential to achieve a high level of service quality for the rail transportation system in Malaysia. The rail operator is responsible for improving the rolling stock performance, in this case passenger train, to ensure the safety, reliability and availability of service and need to meet passengers' expectation. The issue of the train subsystem and components deteriorate, spare part obsolescence and complexity of maintenance often represent a major challenge for rail operators to maintain the entire system. So the original equipment manufacturer OEM recommended that rail operators must consider refurbishment maintenance for each rolling stock after exceeding half of its design life, normally 30 to 40 years. Refurbishment maintenance aims to extend the train lifespan, sustain train performance, and achieve system reliability. In this case study, the focus will be on the refurbishment maintenance strategy to extend the lifespan and sustain reliability and performance of the passenger urban rail transit system, mainly in Kuala Lumpur, Malaysia. So the data from the maintenance management will be used to identify the subsystem and components required in the refurbishment maintenance activity. Besides, the data established from the technical discussion between the rail operator and OEM will also be considered. With this successful research, it is expected that the rail operators can refurbish their rolling stock fleets efficiently and at a lower cost while maintaining performance by refreshing systems that are still well within their lifespan than buying new ones. Okay, for the problem statement, so the passenger train is a public transport mode to efficiently transport passengers from one destination to another. However, an unreliable train system has affected the train's performance during operation. For instance, the issue of train subsystem and component deteriorate is commonly due to the life cycle design aging and requires a major replacement which incur large maintenance costs. Then, the obsolescence problem related to spare part for maintenance of the train critically affected the routine maintenance activity such as no replacement for the failed component due to technology change that limit the operation of some train fleets. In addition, a lack of technical expertise and knowledge in technology could damage sensitive equipment and components due to the complexity of the maintenance process. The comfort and modern interiors of passenger trains also need to be considered. These difficulties contribute to reliability issues and result in many operational problems such as train malfunction, breakdown and service delay on the main line during operation. As such, it will jeopardize passengers' movements and tarnish train operators' reputation with massive complaints. The needs for effective and efficient public transportation service are crucial to attracting more people to use public transport, hence overcome the issue of traffic congestion. In the context of sustainability of passenger train, rail operators need to explore and adopt suitable transformation method to sustain the train performance, achieve system reliability, and enhance service quality to become a world-class service provider in the future. Nowadays, managing rolling stock end of life has been a crucial concern of rail authorities and asset owners since the public expressed expectation to improve sustainability and minimize the environmental impact of rail transit system. For the research objective, the purpose of the present study is to contribute to an understanding of the refurbishment maintenance strategy that the rail operator should adopt to extend the rolling stock lifespan, sustain the performance, and achieve the reliability of the passenger urban rail transit system in Malaysia. The specific objectives are also described as below. Number one, to analyze the performance rates of the rolling stock subsystem and components. Number two, to identify the critical rolling stock subsystem and component based on the performance rates obtained. And last, to propose a refurbishment maintenance strategy to extend the rolling stock lifespan, sustain performance, and achieve system reliability. So the scope of research, so the parameters of these studies, of these case studies have been identified and limited to the area as described below. So number one, understanding the typical maintenance strategy applied in the rolling stock maintenance environment. Number two is understanding the process of identifying critical components such as performing risk analysis. Then number three, to study the sample of train subsystem and components performance rates obtained from the maintenance management database. And number four, the exploration of new technologies and innovation by the rail operator to avoid obsolescence problem. Number five, technology transfer requirement in the rail industry to produce local technical expertise and technical assistance using technology and innovation such as adopting the Industrial Revolution 4.0 in the rolling stock maintenance strategy. And then lastly, the importance of modernization for future railway design concept, especially for rolling stock, the impact, benefits and resources such as hydrogen fuel can be an option for the train power supply. Study the potential transformation model such as recycling rolling stock by conducting refurbishment maintenance. Okay, we continue with chapter 2, literature review. Okay, rail transit system in Malaysia. So in Malaysia, rail transportation system is now categorized into urban, suburban, and intercity. Then rail transport in Malaysia consists of heavy rail, including commuter rail, LRT, MRT, monorail, airport rail link, and a funicular railway line in Penang. So in principle, all the railways infrastructure and service operation are different for each railway line. So then here is the list of rail operators in Malaysia. So number one, we have KTMB, the operator, operate ETS, commuter, freight, then airport link, Kuala Lumpur to Subang Airport. Then number two, we have Prasarana, the asset owner, and Rapid Rail, the operator, operating LRT1, LRT2, monorail, and future LRT3. Then number three, MRT Corp, the asset owner, and Rapid Rail, the operator, operating MRT1, MRT2, future MRT3, and RTS Link. Number four, we have ERL, operate Airport Link from Kuala Lumpur to KLIA. And then number five, Penang Hill Railway, operating cable car rail system, funicular. Okay. And then number six, we have Sabah State Railway, operate the regional for passenger and freight diesel loco. And then number seven, Future MRL, operating ECRL, East Coast Railway Link, Kuala Lumpur to Kelantan, Tumpat. Then number eight, we have Future High Speed Rail, managed by MyHSR, Kuala Lumpur to Singapore. And then last, we have Future Sarawak Metro operating the ART. Okay, urban rail transit system. Urban rail transit system are getting more popular as it seems to be an alternative for urban transportation. For example, in Kuala Lumpur, due to their punctuality and less hassle during peak hours. Okay, this is important to reduce congestion during peak hours, cope with future population growth, enhance and create the image and landscape of a modern city, and reduce air pollution due to vehicular carbon emission. Okay, the needs for an effective and efficient urban transit system are more pertinent as population growth is getting more rapid due to the current economic need for more human resources. The introduction of new technologies in train transportation has been able to attract more public commuters to use train service than private vehicle and buses, as train transportation is proved reliable and more punctual services. For instance, LRT Kelana Jaya Line. So, the LRT Kelana Jaya is a medium capacity light rail transit and the first fully automated and driverless rail system in Klang Valley, Malaysia. Okay, their rolling stock consists of the following model are described in table 2.1. For example, we have 2 car 35 set and then 4 car 35 sets. And then the new 4 car 14 set and 27 sets, which 8 sets already in operation since 2020 and 19 sets delivery to start in July 2023. Okay, railway maintenance concept. The typical maintenance strategies used in railway industry, okay, especially in rolling stock, as shown in table 2.2 below. So we have 6 maintenance strategy. First, we have corrective maintenance, preventive, overhaul, then refurbishment, condition-based maintenance, and predictive maintenance. Okay, maintenance activities are classified into 3 different levels, as shown in table 2.3 below. So level 1, normally we do the cleaning and also replacement of consumable. So this considered as the corrective maintenance. And also we have the routine preventive maintenance. Then level 2, we have complex preventive and corrective maintenance. And then number 3, level 3 is the special maintenance and overhaul and system enhancement and renewal. The entire maintenance strategy, plan, process, and execution is based on risk-based and liability center maintenance principle. Okay, for instance, Kelana Jaya Line LRT, the system downtime is minimized through the detection and correction of failures before affecting the service level throughout the system. This is accomplished by incorporate the following criteria. Number 1, implement careful plan inspection, preventive maintenance. And number 2, define the degree of maintenance necessary for each element. And then number 3, keeping adequate spare parts, special tools and test equipment. Okay, and then lastly, operating an effective fault failure and maintenance reporting system. Rail operator challenge and rolling stock maintenance. So the nature of maintenance in rail environment is complex, particularly regarding the rolling stock. Okay, Malaysian rail operators encounter the challenge of improving their service quality and reliability to offer competitive service and enhance their importance as a road alternative. Okay, rolling stock is the most critical and requires proper attention to sustain the performance. For instance, number 1, the train subsystem and component deteriorate due to aging and obsolescence. Rolling stock reliability and performance may change during its lifetime due to the age-related deterioration, obsolescence, and operating environment. When technologies are upgraded, rail operators encounter limitation when perform maintenance activities due to the technology is obsolete and cannot be accessed at the operator level. For example, table 2.4 below shows general sign of deterioration and problem that the rail operator observed during the maintenance. Okay, so this is the example. Number 1, problem wear and tear. Then number 2, we have problem with wires, the piping and hose. And then problem with the relays and contactors. And then problem with the unstable VAC, the aircon system, structural fatigue, the corrosion, loss of resource, skills and expert, lack of spares, lack of overhaul process visibility. For example, the part numbers. Then we have lack of support from relevant parties. Okay, and then different life cycle of components. Then new technologies. And then lastly is the obsolescence. Then number 2, the challenge that encountered by the operator is complexity of the maintenance process. So the following are the common issues related to the complexity of maintenance. Number 1, the OEM maintenance procedure and resources was limited and sometimes incomprehensive. Rail operator only perform routine preventive, corrective and overhaul maintenance based on the maintenance manual provided. Number 2, maintenance under the rail operator is limited to level 1 and level 2, while level 3 and above need to be assessed by the OEM. Then lastly, take longer time if need support from OEM, such as if require repair, rectification, modification, and etc. Proper arrangements or proposal for managing these technical issues are required. It must involve the OEM to provide a comprehensive solution within the time frame to avoid any major disruption, such as collision, derail, and any incident that could impact performance and especially the safety of the passenger. Okay, then next, managing rolling stock end of life. Okay, all rolling stock are expected to operate reliably and economically. However, some system and components will invariably have to be repaired, overhauled, or replaced during the maintenance. When rolling stock starts showing signs of excessive wear or when the system's unreliable reach unacceptable level, rail operator face two alternatives. Okay, number one, either to purchase new rolling stock or refurbish existing vehicle. Both options need to be evaluated by the rail operator in order to sustain the operation, especially for passenger rolling stock. Refurbishment is probably the most suitable option when it comes to cost efficiency, as it can increase their lifespan by dozens of years or more and at affordable price. Okay, then next, rolling stock refurbishment maintenance strategy. Rolling stock refurbishment maintenance is a strategy to maintain the train that include rectify, overhaul, and upgrade works to restore the train condition and improve the system. It involves reprocessing used equipment at a minimum cost to ensure that the train's performance is within the limit of what is considered acceptable for use. It also involves redesign and upgrading critical function to manage aging and obsolescence to enhance the operating system. Refurbishment maintenance can mitigate the issue of train maintenance complexity by bringing knowledge and technology directly to the end user. It offers a cost-effective way to improve passenger experience and ensure capacity is maintained. It also creates an opportunity to reuse old rolling stock and reduce the cost of acquiring new equipment. So lastly, train midlife refurbishment. Okay, the standard train design life cycle is around 30 to 40 years, and the train condition is to be maintained to meet its performance requirement and customer expectation. Okay, for instance, midlife refurbishment is a process conducted in many industries to improve or extend lifespan of assets such as machine, infrastructures, and system. It is usually done when the asset, such as a train, reach at least half of its design life. For train midlife refurbishment concept, it objectively to enhance the following. Number one, extend the train service life. Number two, improve the reliability of train when fitted with new equipment. Then number three, improve train performance and functionality by installing new technologies. Number four, improve train comfort through new interior design and equipment. And lastly, revamp train appearance. Okay, table 2.5 below shows example of train midlife refurbishment that have been carried out by the rail operators in Malaysia and also the other countries. Okay, from the table we can see from Malaysia, Rapid Rail Kelana Jaya, then from Netherlands, Net Trains completed midlife refurbishment, 50 sets of the DZ type refurbished, then Hong Kong. The operators MTR Corporation completed midlife refurbishment of Metro Camel EMU train. And lastly, Singapore, the operator SMRT also completed midlife of the Kawasaki Heavy Industry C151 trains. Chapter 3 is research methodology. So, introduction. This research started with identifying the issues, establish the problem statement and research objective, followed by the literature review of the existing rail transit system in Malaysia. It described relationship between urban rail transit system, railway maintenance concept, rail operator challenge in managing rolling stock maintenance and end of life, and also the refurbishment maintenance strategies such as midlife refurbishment to optimize rolling stock system. Next process was the primary and secondary data collection based on the historical data collected from Rapid Rail Kelana Jaya Lines Maintenance Management Database involving the 2 Katrin 414 series and 4 Katrin 818 series. The descriptive analysis method for data analysis was applied and the expected findings were also highlighted. Case study framework. Rapid Rail Kelana Jaya Line was selected for a case study because of their experience managing the midlife refurbishment maintenance of the 2 car train. The MLR project commenced in June 2012, conducted by Prasarana Malaysia as an asset owner, Rapid Rail Kelana Jaya as the operator, and Bombardier Hatasuma Consortium as the contractor. The refurbishment maintenance initially begins with 10 sets of 2 car train. In 2017, additional scope of work commenced where two car trains were permanently coupled to form a 4 car train. For better understanding and to gain more knowledge of refurbishment maintenance strategy, the historical data collected was studied and analyzed. The historical data consists of 2 car trains refurbishment maintenance official records and the 4 car train performance data from year 2020 to 2021. Data analysis results were presented and discussed, including the completion of the 2 car train refurbishment maintenance outcome. Data collection method. The primary data collection is based on a review of the 4 car trains for performance, while the secondary data collection is based on the review of documentation established in the 2 car trains MLR project. A systematic process of raw data collection has been done to ensure the fact, figures, and other necessary information were reviewed and organized. The data collection focused on the following. Number one is the 4 car train performance history, and number two, the 2 car train MLR project documentation. Train performance review. The source of primary data collection is the SCADA monitoring system log. The SCADA logs are important to assist the maintenance analyst to analyze alarm summary details, such as identifying the related train subsystem failures and the train ID, the period, and the frequency of failures. Operational data is collected to measure the operation performance and to be used in the improvement work. Evaluating the train performance data is essential to observe the train failure events pattern, obtain the failure rates, and identify the critical train subsystem and components. For instance, number 1, figure 3.1 shows example of daily event log by SCADA monitoring system. And then figure 2 below show example of daily event triggered by 4 car train sorted by the maintenance analyst. So this is SCADA log, the example taken on 1st September 2019. And then this is the forecast trade alarm log after sorted by the maintenance analyst. So data example on February 2021. MLR project documentation review. The source of secondary data collection is based on a review of approved documentation established in the midlife refurbishment maintenance project planning. Project team, inclusive asset owner, operator, consultant, contractor, and OEM, conducted several meetings and discussions to develop the proposed planning for rolling stock refurbishment maintenance. For instance, number 1, figure 3.3 show the overall MLR project plan. 3.4, example of MLR project contract agreement. And then table 3.1, example list of final design review document developed in MLR project. And then table 3.2, the list of method statement developed in the MLR project. So this is figure 3.3, the overall MLR project plan. Okay, we have the section of safety, quality, product introduction, the contract, production, engineering, and the technical publication. This is the contract agreement in the MLR project. Okay, this is the final design review document developed in the MLR project. And this is example of the method statement developed also in the MLR project. Okay, data analysis method. The descriptive analysis method was used in the data analysis, the train performance evaluation, such as perform failure event analysis, calculating the failure rates, and identify critical subsystem and components, were statistically summarized. The data analysis focused on the following. So, number one, analysis for train failure event recorded as SCADA log. Analysis for train subsystem and component failure rate. Identification of train subsystem and components, aging and obsolete. Understand the process practice in MLR project. Train performance analysis. Train failure event data extracted from the SCADA monitoring system log were analyzed to observe the train failure event based on the fault code, FC code, as listed in table 3.3, was designed as a primary indicator to assist the operation control center and maintenance team in monitoring critical failure and identify relevant subsystem that created the problem. So this is the category of alarm. We have FC code number 1 until 15. Okay, figure 3.5 and 6 below illustrate the example of train failure event analysis based on the fault code recorded in year 2020 and 2021. So this is the first 3.5 figure about the train failure event. Okay, we see here FC1 until FC15, and then the number of cases of failure event are recorded for each of the FC code. Okay, and the next here is figure 3.6, the train failure event recorded in year 2021. Okay, then figures 3.7 and 8 illustrate example of train performance summary based on the train subsystem recorded also in year 2020 and 2021. So first figure 3.7 is the train performance summary in year 2020. So it is based on the train subsystem. Then the number of the failure recorded by the train subsystem also recorded and shown in this figure. So next is 3.8, also the train performance summary in year 2021. In summary, the highest 5 subsystem, the automatic train control, the brake system, propulsion system, air conditioning system, and door system were found to have deteriorated, probably due to aging and obsolete. All these critical subsystems need to be addressed in the refurbishment maintenance to avoid major train breakdown during services. Compared to MLR project, the contractor was responsible to notify the project team if any subsystem and component were found aging and obsolete. For instance, figure 3.9 and 3.10 below show example of the technical proposal and general statement provided by the contractor due to the two-car train traction system technology was obsoleted. Okay, 3.9 here. One of the propulsion control unit found obsolete in the MLR project. This is the technical proposal provided by the contractor. And then general statement from the OEM with regard to the propulsion control system that has been found obsolete. Train refurbishment maintenance process. Referring to the MLR project, refurbishment maintenance program was divided into 3 main tasks, where the contractor must address the following scope of work. For example, number 1, rectification for car body and subsystem. Then number 2 is overhaul, selected subsystem that require to be overhauled. Then upgrade, which also selected subsystem, selected system to be upgraded and form car train. Okay. For instance, table 3.4 below summarize general scope of work to be carried out by the contractor for each of the two-car train subsystem in the refurbishment maintenance activities. So this is the example of train subsystem recommended for refurbishment. Okay, from number 1 until number 13, we have listed which required to be rectified, overhauled, and to be upgraded. And additional trees from item 14 until 16, which also required to be installed as a new installation in the MLR refurbishment maintenance project, which is passengers information system, CCTV system, and rail lubrication system. Rectification process. The rectification process in MLR project requires all such systems to be evaluated by the contractor before performing the refurbishment maintenance. For instance, joint inspection between rail operator and contractor was conducted before the handover of the selected train for refurbishment maintenance. Comprehensive inspection was carried out in static and dynamic to observe functionality of train system, including the condition of the train interior and exterior. During inspection, every defect, abnormalities, active failure alarm, physical condition, etc. was recorded in the inspection checklist. So figure 3.11 shows the example of the inspection checklist. Okay, so this is the example of train receiving inspection report. Overhaul process. In MLR project, selection of subsystem and components required to be overhauled was according to the agreed decision. Consider the recommendation by the rail operator based on their experience of maintenance and also the availability of existing train subsystem and components technology. The method applied for the overhaul activities was based on the recommendations stipulated in the maintenance manuals. In this case, the OEM's overhaul maintenance manuals as shown in figure 3.12 was referred. Okay, so this is the overhaul maintenance manual provided by the OEM. System upgrade process. System upgrade was required when the original subsystem and components were aging and obsolete. In MLR project, contractor must find a replacement for the existing aging and obsolete subsystem to ensure the train is work and interface correctly with other train subsystem and other railway infrastructure. The sample in table 3.5 and 6 were the traction system components that were found obsolete. The existing obsolete was manufactured by the Alstom and the proposed replacement was made by the Bombardier Propulsion Power Control. Okay, this is table 3.5, the obsolete propulsion control unit. So in the table, show the equipment description and also the specification. Okay, the major significant difference we can see for the old propulsion unit required 2 unit per car or 2 unit per coach. Okay, and then the replacement of the new propulsion control system. Also, the table show the equipment description and specification. But in this new system, require only 1 unit per car or per coach. Data analysis discussion. So the data analysis define the essential requirements before implementing rolling stock refurbishment maintenance. It also assists the organization in predicting the asset condition to improve operational reliability and make maintenance more effective in the future. In summary, the analysis was conducted to observe the relationship between the train performance analysis and the need of refurbishment maintenance strategy to sustain the train performance and achieve system reliability. A refurbishment maintenance requires a proper schedule and planning to avoid delay and affect the safety and reliability of the system. Therefore, each process in refurbishment maintenance must be identified and organized to ensure the success of the maintenance program. Okay, chapter 4 for result and discussion. Expected result. So rail operators are increasingly faced with various rolling stock system issues, such as train breakdown due to aging subsystem and components, and rolling stock technology obsolescence. Besides, the complexity of the rolling stock system also led to poor maintenance process. These situations impact operation and maintenance, where there was significant increase in operating costs throughout the life of the train. Thus, this refurbishment maintenance is expected to serve as a method to sustain the reliability and performance of the passenger train in railway industry, especially for Malaysia urban rail transit system. Furthermore, it is expected to resolve the lack of maintenance issue and improve future maintenance by having a transfer technology, produce local technical expert, skill enhancement, and etc. In addition, this refurbishment maintenance concept is also considered a part of railway modernization plan. Okay, so this is the list of references. Okay, so I would like to thank again for giving me the opportunity to present my dissertation once. Thank you so much. Assalamualaikum and salam sejahtera.